Hello students, welcome back. So this is our exercise problem 2.19, which asks us to find the values of current I1 and I2 in this circuit in figure P2.19, which is given here. Similarly, in part B of this question, we have to find the voltage V0, and at the end we have to verify that the total power developed by the source is equal to the total power developed by dissipated by the circuit elements. So now, in order to find the elements here, first of all we have to find the values I1 and I2. So to find the values I1 and I2 in this circuit, we have this current source, two currents which we have to find, which are flowing through these values. So now here we can see that these two resistor 150 ohm and 250 ohm are basically in series, so we can combine them like here. Okay, so now in series these two will add together, so 150 plus 250, and it will give us 400 ohm. This one is 100 ohm. This is the current source 1.5 amperes, which is providing us some current. Let us name it I0. Some current is divided and flowing through it, which is called I1, and the other current which is flowing here, we named it I2. In order to find the values of I1 and I2 here, we have a law which is called the current divider law. Okay, so according to the current divider law, if we want to find out the value of I1, so here we will write the value 400, which is the other resistor which is in parallel to the resistor through which we have to find the current, and similarly the values of the resistors which are added together multiplied by the total current. So putting values here, we will get I1 equal to 400 by 500 multiplied by 1.5, and ultimately we will get 1.2 amps. Similarly, to find out the value of I2, so now the resistor under observation is 400, therefore we have to consider the other resistor in our formula. This is the oral proof which we will derive in our lecture series. So now here it is 100, again the sum of the two resistors which are in parallel, and multiplied by the total current. Here I2 will be equal to 100 by 500. Sorry, this is not the 500 but 400. 500 multiplied by 1.5, and we will get 0.3 amps. Okay, so this is 1.2, this is 0.3, and according to the KCL, we can see that the current going towards a node is equal to the sum of the currents which are going away from a node, and hence I0 is equal to 1.2 plus 0.3, which is 1.5 amperes, and which is also I0, and hence it has proved the KCL. So part A is we have solved the circuit for part A. Similarly, to find the voltage V0, we know that these two elements are in parallel. Okay, so we can see here, and in parallel the voltage remains same. If this is V naught, so similar voltage V naught is here, and let us solve it, this one. So V naught is equal to, these two are in parallel. Here we have this current, this we have I1, we have the resistance, so we can easily find out the value by I1 multiplied by 100. So putting values here, I1 is equal to 1.2 multiplied by 100, so it will be equal to how much, 120 volts. So the value of V naught is 120 volts. To find out the power dissipated in the elements and the power developed at the source, we know that for a source the power provided by the source is equal to IV. So the total I here is this V naught, the total current is this one, so V naught here is 120, the total current is 1.5, and multiplying them together we will get 180 watts. Okay, so this is the total power supplied by this current source. Similarly, the power dissipated by this 100 ohm and then this 400 ohm can be calculated by this formula, I square R or V square divided by R. Let us use this formula because we know the values of current which we have calculated. So this will be I1 square into R1, which will be equal to I1 is how much, 1.2 whole square multiplied by the value of the resistor, which is 100. So we will get here 144 watts. Okay, this is the power, this is the total power which is provided by the source, this is the power which is consumed at PR1. Similarly, to find out the value which is consumed across this 400 ohm can be calculated here as I2 square into R2, and putting values here, 0.3 whole square multiplied by the value of the resistor, which is 400, and ultimately we will get it 36 watts. So this is the value here, and now we can see here that PS is equal to PR1 plus PR2. We have to find it out that whether it is true or not. So for it we have to add them. Okay, PR1 plus PR2, adding them together we will get 144 plus 36 watts, which ultimately gives us 180 watts, which is equal to P of S. So it basically endorses this thing that the overall power provided by the source is equal to the power dissipated by the connected resistors. So it was the solution of exercise question 2.19, and I will see you